Today's video lesson has us describing polyatomic ions. We are asked on the bottom of page 10 to define a polyatomic ion. So tools that we should have out, if you don't have them already, make sure you have your notepad open to page 10. And also make sure you have your periodic table, because on the back of that we have our polyatomic ion chart. We are going to create ternary ionic compounds using polyatomic ions. Lots of new vocabulary today being introduced, and we'll start slowly, but these are the tools that we'll need out. Our notepad, page 10, and the polyatomic ion chart, which is on the back of the periodic table. Let's begin by defining a polyatomic ion. We will write a group of covalently bonded atoms, comma, acting as a unit carrying a charge. Repeating, a polyatomic, poly, that word poly, that prefix is many, many atoms together. Polyatomics are many atoms, groups of covalently bonded atoms acting as a complete unit. They just happen to be carrying a charge. Most polyatomic ions carry negative charges. We will identify those and also realize there are one positive polyatomic ion, and I'll show you that in a moment as well. On the back of our periodic table, to begin introducing the polyatomic ions, notice that they are groups of atoms, lots of them, poly means many, groups of atoms acting as a unit, carrying a charge. Let's get used to looking at the organization of the polyatomic ion chart. I see that there is a group of polyatomic ions to the far left that are placed there because they carry a -1 charge. That is the largest list. There is a second group in the middle area that are carrying a -2 charge. And to the far right, there are a few of them that carry a -3 charge. Also, we notice one positive polyatomic ion whose formula, NH4, carries a +1 charge, acting as a unit, 4 hydrogens and 1 nitrogen. That's one unit of atoms carrying a +1 charge. Its name is ammonium. Just as we learn any foreign language, we have to hear the names to start recognizing their sounds. Let's begin, and please follow along on your polyatomic and just listen to me say the names of the following polyatomic ions. The first, with its formula H2PO4, carries a -1 charge, is called dihydrogen phosphate. Dihydrogen phosphate. The second in our list, C2H3O2, carries a -1 charge. Its name, acetate. Acetate. HSO3, -1, hydrogen sulfite. HSO4, -1, hydrogen sulfate. HCO3, -1, hydrogen carbonate. Please take your pencil and add on an alternate name as bicarbonate. Add that on. HCO3 is often called bicarbonate. We might also hear it called hydrogen carbonate. HCO3 -1, two names by that. NO2 -1 is nitrite. NO3 -1, nitrate. Here's an unusual ending, cyanide, CN -1. Hydroxide, OH -1. Permanganate, let me repeat, permanganate, MnO4 -1. Hypochlorite, ClO -1. I know that might look like a Ci, that's Cl for chlorine, ClO -1, hypochlorite. ClO2 -1, chlorite. ClO3 -1, chlorate. ClO4 negative 1, perchlorate. I'll come back and visit this family of polyatomic ions and describe what's happening with the name versus the number of oxygens. Let's also listen to the names of some common negative 2 charged polyatomic ions. HPO4 negative 2, hydrogen phosphate. C2O4 negative 2, oxalate. I'll say it again, oxalate. SO3 2 negative, sulfite. SO4 2 negative, sulfate. CO3 negative 2 is called carbonate. CrO4 2 negative, chromate. Cr2O7 negative 2, dichromate. SiO3 negative 2 is silicate. I needed to add IO3 negative 1 iodate. There was no room in the negative 1 column. There was some spare room here in the negative 2. It is indeed a negative 1 handwritten in, but I only had space to do in the negative 2 area. Iodate, IO3 negative 1. Listen to the names of the negative 3 common polyatomic ions. PO3 with 3 negative charge is phosphite. PO4 3 negative is phosphate. AsO4 3 negative is called arsenate. And our one and only positive polyatomic ion is called ammonium. NH4 carrying a +1, ammonium. We need to hear the sounds so they become familiar. Let's make some observations related to the chart. When I come down to this family of ions that all had chlorine in them, notice the only difference as we went from one to the next was adding on an oxygen. An observation you make might be, I notice with the lowest number of oxygen, I have a hypoite. I add on one more oxygen and it's ite. I add on one more oxygen and it's ate. I add on one more oxygen and I get per-ate. Let's describe what's happened. What I call the main polyatomic ion has the ATE ending, chlorate, ClO3 negative 1.